Hello students. So in this video, we'll see what are polynomials and some basic things of polynomials. Okay. So we are going to start with polynomials. Before getting into polynomials, let's learn some basic concepts such as variables and constants. What are variables? Variables and constants are kind of symbols, some symbol. Okay. If the value of the symbol is fixed, we call it as constant. If it is not fixed, we call it as variable. So the name itself indicates variable. It is capable of varying. The value is not fixed. So we call it as variable. If its value is fixed, then we call it as constant. For example, let's say English alphabets, A, B, C, X, Y, all those English alphabets are the best examples for variables. Whereas coming to constants, the numbers, isn't it? This is a symbol. Actually, this is a symbol. We call it as 1 and its value is 1. Okay. 2, 3, 4, or let's say pi. Pi is a constant, right? Its value is fixed. Okay. Whichever symbol, if its value is fixed, we call it as a constant. Or you would have learned in your previous year 9th standard gravitation chapter, gravitational constant, capital G. Okay, so do not think that only the alphabets are constants. Any symbol whose value is fixed. So G, capital G, its value is fixed, right? Gravitational constant 6.65 into 10 to the power of minus 11, if I'm not wrong, isn't it? So this is also a constant. If its value is fixed, we call it as constant. Otherwise, we call it as variable. Okay. Now, another important thing is expression, mathematical expression or algebraic expression. Okay, mathematical expression or algebraic expression. What is a mathematical expression? It is simply the combination of variables and constants. You combine variable and constants. How do you combine? Either by plus sign, minus sign, or into or division. Combine them using any of the signs and we call it as an expression. For example, let's say 5 is a constant, x is a, or let's take y is a variable. Let's add it. This is an expression, mathematical expression. Or if you subtract it also, it is an expression. Or you multiply 5 into y or 5 divided by, all these are mathematical expressions. Now, there is a one important thing known as terms. Okay. If the variables and constants are multiplied, or variables and variables are multiplied, or constants and variables are multiplied, let it be anything. If they are multiplied, we consider that to be a one part or one term. For example, here 5y and 5 by y are considered to be one term. Okay. But whereas here, this, whenever the plus sign and minus sign comes, we consider this to be a different part and this to be a different part. So there are totally two terms here. Let's take another example, 3xy. Now, how many terms are here? If you observe, all the three things, 3x and y, all three are in multiplication. They are multiplied. Therefore, we consider this to be one term. Whereas if I write it like this, 3xy plus 4xz, then this is a one term and this is one term. So whenever plus and minus comes, we consider this to be a different part and this to be a different part. Therefore, there are two terms here. Okay. So this is the meaning of algebraic expression. Now, why do we require for polynomials chapter? Because polynomial is also an expression, meaning it is a combination of variable and constants. I repeated, what is polynomial? Polynomial is also a algebraic expression, meaning it is also the combination of variables and constants. Okay. Now, what is the difference, big difference between algebraic expression and polynomials? Both are same, but there is a small difference, that is the variables involved in the polynomial. For example, let's take this. The variables involved in the polynomial should have only non-negative powers, non-negative integral powers, or I can say the powers of the variable should be whole numbers. Okay. For example, here you got 2. The variable is x, right? The power is 2. It's a whole number. Here the power is 1. It's a whole number. Therefore, this we call it as polynomial. Whereas I've written an example here, 5 by y. Is this a polynomial? No, because the variable involved is y. If you get it to the numerator, usually the variables will be in the numerator. Okay. So if you get it to the numerator, it becomes y power minus 1, isn't it? So here, the power that we have got for variable is a negative number, which is not a whole number, isn't it? Whole number starts from 0, 1, 2, 3, and it doesn't have negative, it doesn't have fractions. Let's take another example. X to the power of 3 by 2 plus 5. This is an expression, mathematical expression, because it has got variable and constant. Okay. But is this a polynomial? No, it is not a polynomial, because the power of the variable is a fraction. Because in whole numbers, we don't have fractions, isn't it? Let's take another example. Root x plus 2. So root x, if you write it in index form, it can be written as x to the power of 1 by 2. Okay, let me give the general one. Nth root x. This n is known as order, this x is known as radical. So write the radical 1 divided by whatever is the order. Okay. So if it is square root of x, if there is nothing inside this hook type here, we consider it to be 2. Therefore, root x can be written as x to the power of 1 divided by the order 2. If it is cube root of x, we write it as x to the power of 1 divided by 3. All these are fractions, isn't it? These are fractions. Therefore, we cannot call these as polynomials, but they are expressions, mathematical expressions, but we cannot call them as polynomials because the powers are fractions. Okay. You should have the powers as whole numbers. Okay. Let's take another example. 4x cube x square plus x to the power of minus 5. Is this a polynomial? Let's check it out. What is the power of this variable? 3. It's a whole number. Power of this variable, whole number. But here you have got a negative number, isn't it? Therefore, this is not a polynomial, but we call this as algebraic expression. Okay. So in other words, every polynomial is an algebraic expression. Okay. But the reverse is not true. Every algebraic expression cannot be a polynomial because this is an algebraic expression, but it is not a polynomial. Okay. So these are the basics. So let me write the definition of polynomials. So what is the polynomial? Polynomial is a algebraic expression. Polynomials. It is an algebraic expression. It is an algebraic expression in which the powers of the variables involved are whole numbers. Okay, let's take an example. X cube plus 7x square plus 2x plus 1 is a polynomial. But if you take this x cube plus x to the power of minus 5 plus 2 is not a polynomial, isn't it? So this is the difference between an expression and polynomial. Now let's look into different types of polynomials. Degree of a polynomial. Based on the degree, we can classify polynomials. Okay. Now, what is degree of a polynomial? It is the power of the highest, it is the highest power of the variable involved. Okay. Degree of a polynomial, it is the highest power. It is the highest power of the variable involved. For example, let's take the first one, which is a polynomial, right? So here, what is the highest power? The highest power is 3. So x cube plus 7x square plus 2x plus 1. What is the degree? Degree of the polynomial is 3, isn't it? Or let's take x to the power 100 plus 1. What is the degree here? The highest power is 100. Okay. So let's take 5. Only 5. Okay, we call this as constant polynomial. Okay, this is known as constant polynomial. And what will be the highest power of this? See, we know that in laws of exponents, any number to the power 0 is 1, right? So I can write this 5 as 5 into 1, and I can replace this 1 by x to the power 0, isn't it? What is x to the power 0? 1. 5 into 1 is 5 itself. We get back the same thing. So what is the highest power? The highest power is 0. Okay, so we call this as constant polynomial. We call this as constant polynomial, and the degree of the constant polynomial is 0. Remember, the degree of the constant polynomial is 0, and this constant cannot be 0. Okay, you can take any number other than 0. If you're taking 0 itself, we call this as 0 polynomial, and the degree of 0 polynomial is not defined. Okay, the degree of 0 polynomial is not defined. Why? Because see, 0 into x to the power 0 is also 0. That's what we did, right? 5 into x to the power 0. X to the power 0 is 1. So 5 into 1 is 5 itself. So the degree of the constant polynomial, we took it as 0. But 0 into x to the power 0 is also 0. 0 into x to the power 100 is also 0, right? Or 0 into x to the power of 1, 0, 0, 0, 0, 0, 0. 0 and anything is 0. So the degree is not defined. Here, what will be the degree of this? Some lakh something, crore something. Here it is 100. Here it is 0. So it is not a fixed thing, right? Of a 0 polynomial, the degree is not fixed. So therefore, we say it as not defined. Okay. So what is the degree? It is the power of the highest variable involved. Okay. Now, based on the degree, we can classify the polynomials. Okay. If the degree is 1, if a degree of a polynomial is 1, we call it as linear polynomial. Okay, let me erase it and write it properly. So first one, linear polynomial. What is linear polynomial? If degree is 1, we call it as linear polynomial. Example, x plus 5 or 3x, 5y plus 2. All these are linear polynomials. The same thing, if I equate it to 0, it becomes linear equation. That's it. Okay. So the general form is ax plus b. Okay. The general form of linear polynomial is ax plus b. Let's get into the next one, known as quadratic polynomial. And throughout this chapter, we'll be dealing with quadratic polynomials. So what is quadratic polynomial? The degree is 2. Okay. So let's take examples for that. X square plus 5x minus 6, or x square minus 25, or y square minus 36. The general form is ax square plus bx plus c. Okay, that's the general form. So here, if you observe, the highest power is 2. Okay. Let's take the third one, known as cubic polynomial. What is cubic polynomial? If the degree is 3. Sorry, the degree is 3. And here in the previous one, these are known as polynomials. And if we equate it to 0, it becomes quadratic equations. Now it is quadratic polynomial. You equate it to 0 or something. It need not be 0. However, you can get it 0. Okay, by doing some steps. So here, this is a polynomial. If you equate to something, it becomes equation. Okay. So let's say cubic polynomial. What is cubic polynomial? If the degree is 3, we call it as cubic polynomial. For example, x cube minus 1, x cube plus 3x square plus 2x plus 1, or x cube minus 25. All these are cubic polynomials. The general form is ax cube plus bx square plus cx plus d. That's the general form of cubic polynomial. If the degree is 3, we call it as biquadratic. Okay. So remember that it is biquadratic. But these three things are very, very important. If the degree is 1, we call it as linear. If the degree is 2, quadratic. If the degree is 3, we call it as cubic polynomial. Now, based on the number of terms also, we can classify the polynomial. This is based on degree. Based on the number of terms in the polynomial, we can classify the polynomials as monomial. Remember, monomial is also a polynomial. Usually, some of you would have this image that polynomial will have more than 4 terms, or 4 or more than 4 terms. If it is having less than 4, we don't call it as polynomial. If that is your idea, that is wrong. Okay. Monomial is also a polynomial. Basically, what is a polynomial? It is a expression with positive powers. Positive powers which are whole numbers. Okay. So monomial is also a polynomial. Okay. But it has only one term. Okay. It has only one non-zero term. The term that is there should be non-zero term. Therefore, can I call 0 as a monomial? No. This is a 0, right? So what I want one non-zero term. That is called as monomial. For example, here, if you observe, this is a monomial, isn't it? Any other monomials? No. That's it. So this is a monomial. Or let me take one more example here. 5x square. This is also a monomial, isn't it? So next, binomial. What is binomial? Based on the terms, if you have 2 non-zero terms, only 2 non-zero terms. Okay. These are known as binomials. See, I cannot write 3x as 3x plus 0 and tell this as binomial. This is not a binomial because this is non-zero, but this is 0. Therefore, there is only one non-zero. Therefore, we call it as monomial. Okay. But binomial, this is a binomial. Okay, this is a binomial, this is a binomial. There are many examples for binomial, isn't it? All these are binomials. They have got 2 terms, only 2 non-zero terms. The next one is trinomial. What is a trinomial? If it has got 3 non-zero terms, only 3 non-zero terms. Okay, for example, this one. This is a trinomial. This is a trinomial. This has got more than 3. In general, if it has got more than 3, we call it as polynomial. We don't have any specific name for it. These have specific name. Only one term. It is also a polynomial, but we have given a specific name for it as monomial. This is also a polynomial, but we have given a specific name. What it is? Binomial. Okay. This is also a polynomial. We have given a specific name known as trinomial. For all other things, we don't have any specific name, so we call them as polynomials itself. So this is based on the degree, and this is based on the number of terms. Now, let's come to a very, very important topic known as zeros of a polynomial. Okay, it's not zero polynomial. Do not get confused. Zero polynomial is different. Zero polynomial is a polynomial which has only 0, which I wrote it. Okay, now I'm talking about zeros of a polynomial. So let's start with zeros of a polynomial. Zeros of a polynomial. Now let's take a polynomial, a linear polynomial x plus 5. And let's take a quadratic polynomial x square minus 9. I've taken 2 examples here. So what is zeros of a polynomial? It is a value. Zeros of a polynomial is simply a value which, when substituted in the place of x or in the place of the variable, the final answer comes out to be 0. For example, let's take this polynomial and let me substitute in place of x as minus 5. So what happens here? Minus 5 plus 5 will give me 0. So zeros of a polynomial is that value. It can be any value. It can be rational number, irrational number, any type of number. In general, we call it as real number, any real number. Okay. That value, when you substitute in the place of the variable and the final answer comes out to be 0, we call that number as the 0 of the polynomial. Therefore, zeros or 0 of this polynomial is minus 5. Let's take this. Now, in x square minus 9, if you substitute x as 3, we get 3 square minus 9, that is 9 minus 9, we get it as 0. Okay. Similarly, if you substitute x as minus 3, x square minus 9, minus 3 the whole square minus 9. Minus 3 the whole square is plus 9 itself. So 9 minus 9 comes out to be 0. So if you observe, this is also 0 of this polynomial. X is equal to 3 is also 0 of this polynomial. Okay. But can I say x is equal to 2 is 0 of this polynomial? Let's check it. In place of x, just put 2. 2 square is 4. 4 minus 9 is minus 5. So which is not equal to 0. Therefore, this is not 0 of this polynomial. Okay. Or let's take x minus 2. This x equal to 2 will be 0 of this polynomial, because if you put x as 2, 2 minus 2 is 0. And if one interesting thing, if you observe here, it is a linear polynomial. What do you mean by linear polynomial? Whose degree is 1, right? Highest power is 1. The linear polynomial has only 1 zeros, whereas a quadratic polynomial has 2 zeros, meaning the number of zeros will depend on the degree of the polynomial. If the degree is 1, we will get only 1 zeros. If the degree is 2, we will get 2 zeros. If the degree is 3, we will get 3 zeros. Okay. For example, let's take x square minus 25. Okay. It's a quadratic polynomial. What is the degree of this? Degree is 2. Therefore, we will get 2 zeros. One is 5, another one is minus 5. If you substitute 5 here, 5 square is 25. 25 minus 25 is 0. Similarly, if you substitute minus 5 here, it becomes 25 minus 25. Again, it is 0. So, the number of zeros of a polynomial depends on the degree of the polynomial. Okay. If the degree is 100, then we will have 100 zeros. Okay. That is 100 values, which when substituted in the place of x or the variable, the final answer will come out to be 0. Okay. This is zeros of a polynomial. Now, what is the graphical meaning of this? The graphical meaning is, if you plot a graph for this x plus 5 and x square minus 9, if we plot for this polynomials, wherever the graph crosses the x-axis or intersects the x-axis. For example, let's say if you plot a graph for this, it'll intersect the x-axis somewhere here at minus 5. Okay. So if you plot a graph, it will intersect at minus 5. So minus 5 is known as 0 of this polynomial, because at minus 5, it will cross the x-axis or meet the x-axis. Okay. If you plot a graph for this, x square minus 9. So it will be something like this. If you observe this graph is meeting the x-axis at 2 points, isn't it? And these 2 points, one will be plus 3, another one will be minus 3. So the graphical meaning is, it is those points at which the graph meets the x-axis. The graph is meeting the x-axis at here. So this is a 0 of a polynomial, and it is meeting here. So this is also 0 of the polynomial. So based on this, let's solve the first exercise. In the first exercise, the graph y is equal to p of x are given for some polynomials p of x. And one more important thing, the polynomials are usually represented as p of x, meaning it is a polynomial in which the variables are x. If I write p of y, then it means it is a polynomial in variable y. Okay. The alphabets that are inside the brackets represents what kind of variables are there. Okay. Let me show it. So here, if you observe, it is p of x, right? So it is polynomial in variable x. Instead of that, if I write p of, let me say, if I write p of y. Okay, then it is polynomial in variable y. Instead of p, I can also take g, h, doesn't matter. Okay, let me take g of x. So g of x is also a polynomial. What is the variable? The variable is x. Okay, yeah. So let's get into the first exercise. Find the number of zeros. We have to find the number of zeros. Okay, the first curve, the first line here, this is the graph. Okay, if you observe, this line is not at all meeting the x-axis, right? So what is the graphical meaning? Wherever the graph meets the x-axis, that point will act as the zero of the polynomial. So it is not at all meeting the x-axis. So number of zeros will be zero itself. There are no zeros at all. But if you observe this graph, it is meeting the x-axis at this point. So the number of zeros for this will be 1. Okay. And if you observe this graph, it is meeting the x-axis at here 1, and here 2, and here also 3. So therefore it has three zeros. Okay, we are not finding what are those values, we are just finding how many zeros. We have got 3 zeros. Coming to the next one, fourth one, it is very simple. At how many places is it meeting the x-axis? It is meeting the x-axis at 2 places, 2 points. Okay, so it will become 2. Now coming to this fifth one, so it is 1, 2, 3, 4. So totally it is meeting the x-axis at 4 places. Therefore the number of zeros is 4. And if you observe here, it is touching the graph or touching the x-axis at 1, and here also 2 and 3. So totally it is 3. Okay, so this is the graphical meaning. So throughout this chapter, we'll be discussing about quadratic polynomial. So in the next video, we'll discuss more about quadratic polynomial. Thank you, students.